Welcome to MyWebUniversity, my YouTube channel. My name is Wahid Lutfi, and I'm going to make this video for you to just help you out in terms of your school, your career. If you're a developer looking for a job or enhancing your career, this video is entirely dedicated for you guys, as well as the students that are taking college courses such as Python programming, R language programming, MySQL, MariaDB, any database courses that are related to relational database, whether you're doing SQL, Oracle, MySQL, Informix, Sybase, any Microsoft SQL Server, or Access, any of them that are relational database, this video is going to help you entirely. I just give you a little bit warning that this video is not at the novice level. However, I'm going to define all the jargons, all the terms that I use here, everything that I use. I'm going to be very, very detailed on it, and I'm going to try to help you out. So stay tuned, you will learn a lot in this course. First of all, on the client side, on this thumbnail that I'm going to post on this video, on the client side, we have Python programming language, R Studio programming language, and Visual Studio Code IDE. I'm going to use the R Studio IDE as well as a Visual Studio Code to demonstrate some of the code written in Python that I wrote, or using the R Studio IDE integrated development environment for R module, which is in this case MariaDB connectivity. Same thing for Python. Both Python and R language is very, very great programming languages that are provided everywhere in the open source community. And then R is a statistical programming language that is mostly used for statistics as well as data science, and then any other mathematics, and because it's written in Fortran, C, and R itself, the modules, so it does support a lot of statistical analysis, data visualization, and data science kind of work, as well as Python is general purpose programming. So for data manipulation and data visualization, both R and Python has modules that support you, as well as data science. There's a lot of modules for Python that support data science. In terms of statistical, R wins, but in terms of general purpose, Python wins. So it's not kind of like one size fit all. You just have to learn both in order to do both of them. In terms of machine learning, obviously Python has a lot of modules, TensorFlow and other ones, pandas for the database, and we have a lot of those ones that are going to come, and I'll discuss. And if you watch my Python courses, I have discussed regular expression, NumPy, and a lot of modules there that is extensive learning. As well as for R language, I did demonstration, a lot of it for data visualization, data manipulation, and then graphic imaging, as well as with Python. So a lot of these things don't just give it kind of credit on one side, since you're exposed to it or you're exposed to Python, and don't give this credit to other ones. They're all great. It's like you telling me that Messi is better or Cristiano Ronaldo, or Pelé was better or Maradona. Any of those players at their own time, depending on who they can interact with, the players that are passing the ball and then being team players, they all have different kind of functionality and features and a skill set that you could just say, at this time, I need somebody to have a power kick, or long shots from 30 yards, 35 yards, or maybe a curveball, and maybe a dribble, maybe a skill that is speed, maybe it's physicality, maybe a high jump. So each one of those person that you look at it, they have like a area that you could benefit at the most. Similarly with Python or language C, C++. If you want to do like game programming, yeah, go ahead with C++ because of speed and or C. C wrote all of them, C++. In C, everything was the mother of all languages. Everything was written in C, although it's not object-oriented like C++ or Python. For example, R is object class-based kind of programming, but it's mostly functional programming. So on the client side, you have a lot of things to connect to a database. Even the command line, like terminal-based or command line from MySQL connectivity or ProC or PL/SQL. There's a lot of Developer 2000 on the GUI, and those tools that are nowadays legacy, but there's a lot of other tools that you can still connect to the database. On the client side, we could also have a localhost DB, which is a structured query language. This SQL stands for structured query language. You can also call it a standard query language. The reason it's called structured query language, when you create a table, you say if the table doesn't exist, if not exist, that if not exist has a structure, as a logical kind of a statement that will validate if the table already exists, it doesn't create it. So it's called structure. You have inside the database management system, DBMS, which stands for Database Management System. DBMS is basically the core part of the database. Like kernel is the core part of the operating system, DBMS is the core part of the database. Inside the database management system, you have these data definition language, data manipulation language, data control language. Each one of these ones are structured to store data, manipulate data, and then control data. So that's why you have data definition language like create statement or drop a statement to create tables, to create users, to create synonyms, to create views, and the same thing you can drop them. That is a storation of database, data definition language. And data manipulation language like select and insert and update, those statements you can also delete. You can manipulate rows and records in the table, on a given table or multiple tables. And then they might have some relationship. You can just join them and then delete records, cascaded delete, or cascaded update with data manipulation language. Data control language is grant and revoke statement that you're just doing granting privilege to a given user. Normally, the data dictionary, which is the system tables, has the entire database, which is kind of like information schema on MySQL, and then on Oracle it's called the data dictionary. And each database, they have their own daemons, they have their own system global area, their own search engines, how it is designed that are different between the database, but 80% of them, they're the same. That's why when I say structured query language, they have a structure to do data definition language, data manipulation language, data control language, and even write stored procedures and triggers and other ones. But they're also called a standard query language. The reason it's called a standard is that you could use a standard query language, data definition language, data manipulation language, data control language inside a MySQL database, inside an Oracle database, inside a Informix, Sybase, DB2, and then a Microsoft Access, SQL Server, any database that is a relational database and it supports a structured query language, and then you can do these kind of data creation, data manipulation, and data deletion. So all of that is, since it's on multiple database instances, it's called a standard query language. It is a structured as well as a standard. So if you're using MariaDB, which I'm using in this example, then you're going to use SQL inside MariaDB, which is a standard query language. The same thing that I did it on MySQL earlier on another video, that I posted, I'm going to do today on MariaDB. So MariaDB is a database instance that was forked off MySQL. When originally MySQL was purchased by Sun Microsystem, later on in 2011, I believe, Oracle Corporation bought or merged with Sun Microsystem. When Sun Microsystem was part of Oracle, Oracle owned MySQL database, and then Java programming language, Sun Solaris operating system, and a lot of other storage stack, a lot of things that Sun Microsystem had it. Now it's called, originally it was called Oracle Sun, now it's called Oracle Corporation. Oracle has MySQL as well as Oracle database itself. So we are going to discuss the MariaDB, which it was forked off of MySQL. All the developers that they thought that open source still should have a version by open source community, they forked off MariaDB, and MariaDB.org was built at that time, and then still supports it on the site as a GNU kind of open general public license. So GNU is stand for GNU is not Unix, but it is open source, and it is a very, very great open source. It has a lot of utilities. The entire Linux kernel was put together, and then now you have all these kind of flavor of Linux distribution, whether it's Debian or Ubuntu or Red Hat or Fedora or Caldera, all of those ones at some point, Rocky, CentOS, all of that one were a combination of this GNU utilities along with the Linux kernel. So that made the operating system together. So I'm going to be talking about MariaDB mostly on this one. There are some kind of slides that I still have from MySQL, and on this one that I'm going to go over, so you could see that there's no difference whether you use MySQL or MariaDB. They're all interchangeably. You can do the same syntax, the same statement within, but you have to load the modules differently. I will show you those parts that are different, the drivers and everything else. So this course is going to be brought to you by my web university, my YouTube channel at youtube.com, and then my channel handle is at MyWebUniversity. I have two channels. One is in English, which is at MyWebUniversity, and one is MyWebUniversity In-Farsi, which is I do it in Farsi language, so to help out my country fellows that are from Afghanistan. And all the Persian spoken people, whether they're from Iran or Tajikistan or any other person that in the world that can speak Farsi, obviously they can understand me on those videos. But this channel is entirely in English, and I hope that it helps you guys. So this course is going to be teaching you Python, R language, MariaDB, a structured query language, all in one video. And I hope I could do a good job to earn your kind of time, and then I do respect your time. So let's get started with what we had last time. This was what I discussed on last video. It was all on my SQL database, and then the same kind of concept. So today I'm going to review those ones, because and this one is on MariaDB. This part is replaced. Everything else on these Python and R modules, I show you that once you learn it in one, it becomes like a template. You write the same Python program, just change the drivers and change some of the statements, some of the import and library modules, and then you're connected to a MySQL database or Maria database or Oracle or SQL Server, Microsoft Access. The read and write of data, opening cursor, all those concepts are the same. Whether you're using a connection onto MySQL through Python, RStudio, or from the actual client software that I'm going to also demo today for MariaDB, Well, I'm going to show you that one also. The client software for MariaDB is called HiD SQL. I'm going to show you that one. For MySQL, I showed you last time was MySQL bench. Well, I'm sorry, MySQL workbench. And so I'm going to discuss what is a DBMS. DBMS is basically the core part of the database. And this is, what does that mean? It's the main part of the database. Everything that manage your database system, whether it's storing the data or retrieving the data, manipulating the data, updating the database, controlling the data, all of that one is done by the DBMS. It's like kernel is the core part of the operating system. DBMS is the core part of the database. And it has languages, syntax like create, create, drop, to create and destroy data definition language, we call it. And data manipulation language like insert, select, and then delete, and then update. Those are data manipulation for retrieving and updating records and to the database tables. And data control language is, again, is just allowing you to control access onto the database. So here I just also define the DBMS in detail. Is a software system that is designed to manage and organize data in a structured manner. This structured manner is important. Like I told you that SQL stands for a structured query language as well as a standard. And I mentioned that this is called the standard because it is a multiple instance of databases such as Oracle, MySQL, Sybase, Informix, SQL Server, Microsoft Access, any relational database, you can name it, MySQL or MariaDB. This is a structured query language is supported. And it is a structure because inside there, it has some logical statement that you can just say, create this table if it doesn't exist, create this user if it doesn't exist, or create this user with this primary key or foreign key, and tie the linkage between them, bind the relationship between a key and a non-key, a primary key and a foreign key. How you bind them together, sometimes they're a relationship of one-to-one, sometimes it's one-to-many, sometimes many-to-many, all depends. It's like one student could have multiple classes, or one student could take one instructor as a class, or one student is assigned to one building number, one major. All of that one could be just relationship with it. So we will talk about that. And again, I said DBMS is the core part of the database. That means the main database is supported because of data definition language, which are defining the data, how you store the data. Whenever you create a table, you're just saying create table and the table name, and then whatever fields and attributes you assign them, primary key, foreign key relationship, you're defining them. Similarly, create an account identified by a password, that is just creating an account, creating a view, creating a synonyms. All of those ones creating a database itself. The database first have to be created, then you create tables inside it. For example, in Oracle, you have a database that is an instance, and then you are creating table spaces inside there. Inside of table space, you create indices and tables itself. So then you have on MySQL and MariaDB, you create a database. Inside the database, you create tables. And then you can create views, you can create synonyms, triggers, and all of that one, and depending on which database I'm talking about. So some of them, they like MySQL is a relational database, where SQL Server is a transaction based. They're all kind of transaction in some ways, but the transaction is atomic, that meaning that it's either done or not done. And then whenever you're submitting a record to be updated in a banking system, obviously that transaction either has to be committed or rolled back. before a earthquake happens, or before the snapshot just gets choked, or some kind of redundancy that is happening between two replica of the database. All of that one, the transaction, the system log and log writer, DB writer, all of that one as a DBA, you have to be watching for those ones to make sure you have backup, you have a snap shots and all of that one. So I'm going to talk about, one of the joke was when I was teaching at National University, I was teaching a database class, and then some of my student, one of them was was at Boeing, and he was always didn't like VI, VI. At that time, there was no Vim, this back 1998. And then Vim is a visual improved. Or VI stand for visual interpreter. And so, and then he was joking with this, like, no, it's not, Wahid, it's not the stand for visual interpreters, it stand for visually impossible. So some of those things, when I was teaching the database class along with the operating system, some of the students, they could be doing the Oracle database or MySQL database on Windows machines. Some of them, they were using Sun Solaris, some of them or using Sun OS, Sun Solaris, or Deco OSF1, or something else, or AIX. But each one of those ones, if you don't know the detail of the operating system and a lot of these tools that you're using it and doing these queries from the command lines, a lot of those tools sometimes in the back old days were all kind of PL SQL, SQL class, and all those things. And developer 2000 coming in 2000, a lot of people, they could have a hard time just manipulating the data or creating a database or doing it if they are not a terminal kind of a person to do it. So I don't know why I mentioned that story, but I was teaching this class. I now I remember at National University back then. So, but through that one, then later on, I taught some courses with MySQL and Oracle class at Cal State Fullerton, and a lot of Python programming and C, C++ courses at Pasadena City College. But the long story short is that whenever you're doing these things, it's just keep reviving. The new version comes and new tools are adding, and just keep growing. And then you have to learn. Education and learning never stops. Some of us have been a student forever. So, and just do the best you can, and then hopefully you will enjoy your life. And then it's designed with data control language as well. So grant and revoke, and then that's that part. Now we're going to talk about what is normalization. Normalization is a process to eliminate anomalies. What type of anomalies are there? So when you create a table, usually you have a number of attributes, which we call it columns, and these attributes together makes a row of a record into a table. So a table is consists of attributes and rows, or so we call it tuples and attributes in a relational database. And in a regular database, you call it columns and rows. So when you're just inserting records, if the record can allow multiple element attributes to be duplicated or redundant, then it has insertion anomalies. Insertion anomaly is something that should be eliminated by normalization of the database. And then similarly, the update, if you update a record, let's say the professor name changes for a given class, and then all of a sudden you update it, one or more record gets updated, but there's inconsistent records on the database that did not get updated because there was no primary key, foreign key relationship with different tables, or with major table or with course table or something. So those update anomaly could happen because the data becomes inconsistent with what changes were supposed to be done. Similarly, you delete a record, you might have wanted to delete maybe 5 records from that one that matches that criteria. We call it where clause in the data manipulation language. When you say delete from this table where this condition is true, the where clause, you might have just specifically said where that condition is true, but that condition might have deleted more than just one row or 10 row, because there was no entity saying that this is a unique record, that there's no primary key, foreign key relationship. So database was not normalized. Since you inserted it, allowed you multiple record for just Wahid as a user and a student name or as a professor name. You have similar information that you could duplicate the insert of the person's attributes name. That column could have had 10 records of the same kind of data because there was no normalization. Then now you're deleting it, delete all 10 of them. So those are anomalies that could have insertion, update, or deletion. Similarly, in a database, we use a key, primary key, foreign key, candidate key, alternate key, which I'm going to talk about all of that one, unique key, composite key, a lot of them. I'm going to be discussing those ones also. You use those keys to normalize a database by breaking a larger table, a table that has maybe 10 attributes or 10 columns. You could call it columns or attribute. And relational database is called attribute, and then the regular database, we call it columns. And then row would be called tuple in relational database, and then on the regular database is called rows. So when you break the larger table into smaller tables, you're trying to make sure that each table, that the smaller table, does not have the insertion, update, deletion anomalies. As long as it doesn't have it, then now you are just in good hand. You just basically normalize it. And then here I just say the same thing almost by decomposing a larger table into a smaller, well-structured table. Well-structured meaning that primary key, foreign key relationship, and the candidate key, non-keys, and the unique keys. All of those ones, you go through those 5 normal forms to make sure that you follow all those processes or rules to make sure your database is normalized. So I'm going to show you after this all those rules. And then basically what structures, and you have to find out relationship between them. That's why it's called relational database. It's a relation between one key versus the other one's foreign key and secondary. Sometimes a secondary key is also called foreign key. So a primary key matching a foreign key of another table, that's why it's called foreign. It's a foreign to another table. That there's a relationship between them and you find them. So there are a number of keys. First, let's discuss what is a primary key. A primary key is one or more field that makes a record unique in a table. So you have a table, whatever number of fields that makes a record unique, then and that is the primary key you choose. And then that could be one field or multiple fields. So one or more fields that makes one or more columns, you could say, one more attributes or fields, or all interchangeably is okay. One or more attributes that makes a record unique into a database, a table, is called primary key. Secondary key is also like primary key, but it is a key in the second table or foreign key on another table. That's called why it's called foreign key, that matches a primary key of another table. So foreign key and secondary key are interchangeably used. Alternate key, before I discuss the alternate key, let's talk about candidate key. So if you have a student table, the student ID, student name, student um, first name, last name, subject, and department ID, and all of that one could be one of the key. They're all candidate to be chosen as the primary key. That's why it's called candidate key. They're all candidate, all those attributes are candidate to be the primary key of that table, a student. And then once you choose that primary key, saying that, well, student ID and the student first name, last name, and subject is the primary key, then now everything else, all the other key that you did not choose, are considered alternate key. That's why the word alternate. They are alternate to be the primary key. So you can alter a table, then later on just change the configuration. On the alter statement is one of the statement that you defining and the data definition language. As you create the table, later on you could alter it. I will show you some example of that one also. Composite key is like when sometimes like address information. Address information is made up of multiple string, like 384 Banana Drive, Dannenberg, California, 91765, or 120 Twilight Street, Placentia, California, 9175, whatever. 2020 some address, Golden Spring or whatever, right? So you have that as a composite address because it's made up of multiple strings, which is the street number, city name, and the zip code and the state. All of that information, that's why it's called composite key. And that is more than one field. Unique key, sometimes any key could be defined so you do not allow duplicate. In the example I'm going to show you later on, I created the database department. So sometimes in order to not have multiple key or multiple values for a given department, you have to just define the department name into a unique key. Why you do that one? Because if otherwise you're just gonna put computer science 10 times, it's gonna allow you to have 10 entries in the table. Or you put professor's name 10 times, it's gonna put that one. In order to just not allow that one, you just use the unique key, and that's gonna just allow it the first time. Second time when you use it, there's a constraint for it. It says, I'm not gonna allow it. And then using these keys, we decompose larger tables into smaller tables by finding relationship. Finding links and relationship between them. So you could say, well, the relationship between these two tables is, or rows that are matching one-to-one relationship. So for every person, there's a social security, one-to-one relationship. For every person, there's a DMV record that he or she has the license, non-driving record. And for every person, there might be an account, one-to-one relationship somewhere. And then if there's one-to-many, it's like one person may have multiple houses, or one person may have multiple cars. One person might have multiple shoes. One person might have multiple soccer ball. So for me, multiple soccer ball is true, but multiple houses, multiple cars, sometimes it's impossible. Although I had to buy cars for my family in order to just make sure that they can drive as well. Uh, they have to go to school and everything. So many-to-many relationship is like sometimes you have money building or just allowing many classrooms. So a relationship to this one, or many students could take many professors, or many students could take many subjects. All of those ones are many-to-many relationship there. Let me just go back here. And then the next one is when we do normalization, we want to minimize and eliminate redundancies and duplication. And so we don't have any anomalies like insertion, update, and deletion. Now, how you do normalization. The process of normalization is there are 5 different normal forms, which are called first normal form, second normal form, third bias code normal form, which is similar to third normal form, fourth normal form, and then fifth normal form. When a database is in fifth normal form, then you have no insertion, update, or deletion anomaly. And so that is what you want to just make sure that you can insert the record without duplication. You can update the record without having data inconsistency or integrity of that data. Similarly, you can delete the data. If a person that is, when you're just working for a company, and then let's say I lose my job, all of a sudden I have to just make sure that I support my family, but then the company is going to say, well, since he is gone, we want to make sure that any dependencies that was receiving health insurance, they are not going to receive it. So there's a cascaded delete on all the tables with my record matching my dependencies. Similarly, if I just have some updates saying that, okay, I need to update some additional information into my records. That update has to be done on all those tables when I do have my job. Okay, so let's get back to the next step, which is what is first normal form. So notice that I just changed the kind of slide image here. This MariaDB was a slide that I got it from unsplash.com, or not maybe Unsplash, maybe I picked it up from the CC that is on the public domain. So I'm going to give the credit, this photo is by unknown author, licensed under CC by SANC. And previous ones were all given credit to Azad already on my previous video as well as this one. So this is the new slide that I just made it for this one. And MariaDB is the picture here. Everything else is I posted here. So what is first normal form? And the first normal form, you want to make sure that each column attributes contains, column or attributes, the same thing. Each column contains atomic values. What does that mean? There's 4 rules to do that one. Using row orders to convey information is not allowed. So you cannot use the row order to convey information. For example, if you just talk about GOAT, greatest of all time, and then you just say, well, let's start with Pelé, Maradona, Zidane, Messi, Cristiano Ronaldo, any other, Beckenbauer, John Cruyff, all of those ones, when you list them, each person may give you a different list of those ones. So the order of how I give the name may be different from you, and maybe different from, if you just ask the top 5 or top 10, then each person gave a different list of names, all right? So the row order, how the person says Pelé, Maradona, that order, somebody might say John Cruyff, Beckenbauer, Ozabio, or something else. The order is not going to convey information. That's not accurate. So you cannot say the row order should determine how to convey information. That's not permitted. That's what does that mean. Mixing data type with a same column is not allowed. So the same column, let's say player name, cannot have a string or a var character 2 as well as integer. The 2 different data type cannot be matching it. So whatever you define for the attribute or column, a data type that is consistent for that column. You cannot mix and match it. Each table must have a primary key. Obviously, a table, when it has a primary key, you're trying to eliminate duplicate column on a given table. So that's what is a primary key is important on each table. repeating groups are not allowed. Obviously, repeating groups, sometimes you're giving three fields, for example, first name, last name, address, and then you're just doing customer ID information, and that information is repeated like 3 times or 10 times because they bought different items. So that information should not be just stored into the database or retrieved from the database multiple times. And that's what, when you normalize it, the retrieving and storing database and querying database becomes much faster by not allowing repeated groups into the database. Second normal form is each non-key column. Each non-key, this is important, non-key column attributes in the table must be dependent on the entire primary key. So if you have like 3 other fields like first name, last name, subject, and then something else, whatever those other attributed columns are, they must be depending on the entire primary key. And the example of a student, for example, student ID is the primary key, then you want to just make sure that the rest of the non-key, meaning that they're not part of the primary key, then they all depend on the entire key. So that's second normal form. And third normal form is similar, but it is also saying that each non-key column attribute in the table must be dependent on the key. So we said the same thing, but we said a second, the entire key. So if the key is 1 or more field, then it's going to depend on those 2 field or 3 field or 4 field, and nothing but the key. So it should not depend on another non-key column, but only depend on the primary key of that one. So that way you have, and I think this is, I believe, yeah, and this is already explained the third normal form. So I'm going to go to the bias code normal form. Bias code normal form, it says each attribute, and the previous one was saying each non-key. Now we're saying each attribute. So attribute could be any column. Each attribute in the table must be dependent on the key, the whole key, and nothing but the key. So it could be just dependent on the key, every attribute, the whole key, which is if it has one field as primary key, it's going to depend on that one field. If it is 3 field as the primary key, the whole key, which is the whole primary key, and then nothing but the key. And nothing but the key, that means one attribute cannot depend on another attribute. And then a fourth normal form, it says the only kind of multi-value dependencies allowed in the table or multi-value dependencies on the key. So multi-values are only dependent on multi-value dependencies, which are on the keys. So they if they are multi-valued dependencies on the key itself, then it's okay. Otherwise, that multi-values are not allowed. And then the last one is the fourth normal form. If by this time, if you had done first normal form through fourth normal form, in order to make sure that your database or tables are in a fifth normal form, and then you say my entire table is normalized, is to make sure that it must not be possible to describe a given table as being result of joining other tables. What does that mean? So if you could break the table into smaller tables and still could join them, then break it. If you say that it's not possible to describe a given table as being result of joining other table, then you're in fifth normal form. So on this one, I'm showing you that the same DBMS could be on a SQL Server, which is a Microsoft SQL Server for Windows platform. As you can see, Microsoft SQL Server is also, I think, it's open source now, or available for dev stuff, and that you could also do on other platforms, connecting it to through Python or R language or any other programming language, and that you could name of, connect to a SQL server and access it. And this one, I just showed that whether you have SQL Server, MySQL, Oracle, any of them, DBMS is going to do the same thing. It's a software system that is designed to manage and organize data in a structured manner. And DBMS is the core part of the database, whether you're using Oracle, MySQL, In-Farsi, Sybase, Microsoft Access, ID, SQL is the MariaDB client. I'm going to be demo a lot of it on ID SQL. ID SQL is the client version of structured query language that allow you similar to MySQL Workbench. Inside ID MySQL Workbench was for MySQL that I demoed last time. This time on MariaDB, I'm using the client ID SQL. So in a way, I'm doing this video for at least 6 different subjects. Whether you enjoy it or not, I hope you are gonna just make some nice comments, because I work hard for it to help you out. And then database management system, data definition language, data manipulation language, data control language are all part of the ID SQL or MySQL or Oracle, and I'm going to demo that one next. So ID SQL is the client, and that when you install MySQL MariaDB comes with ID SQL, and this is the client. That's again, this image was taken from CC by ND, and so the credit is given there. Let me see the other ones. I already gave the credit, and then the same thing. We're going to just jump in right into ID SQL here. Okay, so first, before I go to R language and other ones, I want to just close this one maybe, or maybe I could just stay here and then show you, since I already brought it up. And let me move this zoom out of my face blocking me. And then right here, okay, we're looking at ID SQL. So I'm going to close it just to let you know that let's just say save everything. And then I'm going to just come back here. And then first of all, if you did not watch the video that was on MySQL with this one, this is the video that you want to watch it. And that one is basically about 3 hours and 20 minutes. Hopefully this video is going to be less than that, because I have had a number of things a little bit faster, and this time covered. I'm going to jump in right into that one. Last time I mentioned about my website on YouTube channel. These are the videos. I'm just going to quickly show you the channel, and it's up to you to just go and enjoy and learn from them. Sometimes I have videos that are 4 hours to 20 minutes long, that teaches the entire Linux Red Hat from 0 to hero, or Rocky Linux Red Hat 9 and then there's a lot of them, advanced PowerShell, Ubuntu for about 6 hours, 2 courses, each one of them. There's a lot of other courses that I'm teaching, like R language, MySQL, Python, a lot of these courses, PowerShell, databases, and so on. So, and then on the website itself, I have MyWebUniversity.com that you're welcome to watch, both on the English version of my YouTube channel, as well as the 4C is here, and then as well as the entire book that I wrote, The Direct Path to Linux Ubuntu. This is about 14 chapters, and there's each one of these chapters by itself is an entire book. For example, some of these PDF files that I just wrote a Python program to generate about 32,000 PDF files on these chapters, whether Rocky Linux, Red Hat or Ubuntu or C++ or Linux Ubuntu or dynamic generation of Linux manual pages that you can go and search for them. All of those ones are available, as well as intermediate, basic, and advanced level of Unix, that each one of them, they have their own tables that you can go and practice them. And if you just click on these ones, you can see like a book explanation of all of that, as well as if you run the command, you could see the output of like systemd. This is processes of systemd, processes stream 3, and you see the output on the browser. So a lot of these things, you're practicing it online, learning it. It's all for you, for your needs to learn. And then there's a lot in there. It's really hard to just explain it on each one of these videos. You have to learn it and enjoy it and practice it, and then do good at your work and at your school, and share it with your friends. When I say knowledge is power, learning it is like make you a hero. You become a hero to save the day for your family, for your co-workers, for yourself, and for the community that you live on. And then you become a hero if you just do one or more of these things. But if you just share it with thousands of other ones, now you become a superhero, or you help others to become hero. And then you generate all these other people, they say generative AI or something. You could clone yourself into thousands of other, could be hundreds of thousands of people that they could do the same. And then by sharing it, you become a superhero, and then help your family and community. Try to share whatever you learn. My job is here to teach you something that I know, and then you can pass it on to the next person. That person is going to pass it to the next person. All of a sudden, we have a better society everywhere. So here I'm showing you the foresee version of my YouTube channel, that I also have a lot of videos here that is in foresee. And then some of these ones, if you look at the videos here, whatever I make sometimes in English, I make it also in foresee. So you're welcome to learn it in foresee if you can understand English. But if you do, it would be nice to learn it in foresee as well as start learning it in English. That way, when you work for your job, you can help yourself as well as do good at your job. And then because everybody else is going to speak English when you work on the computer, IT, and other stuff, whether AI, whether computer science programming, database, system administration, each one of those terms that we discussed, people are going to discuss it in English. So let's get back to the work, not HiDi SQL. So I'm going to just look at the HiDi SQL here, and that one is somewhere in the background here. That's our language, right? Okay. So first, I stopped the HiDi SQL. That's why it's not there. And then now first, you can see MySQL database is running here, MySQL 80. I don't need that one, but last time when we did that one, I showed you a lot of stuff on MySQL Workbench, and we used the world database. So I'm going to stop this one because I say, well, let's just, it is actually, it says the start, and let me say MySQL, and then it is supposed to, it is saying that it is running. Let me just refresh it. I'm gonna just close this one, go back to service here. And then when you go to services, if you see any inconsistency on the database, like I was seeing MySQL, you can also check it out from command line. I'll show you how to do that one. Let me just go to MySQL under M. So MariaDB is running, you can see here, and that's running on port 3307. But MySQL, let's see if MySQL is somewhere here, MySQL is not running. So you can see that earlier it was saying running, it's not running. That was not correct. So I'm going to do netstat here. Netstat minus an, and then find, I'm going to say 3306. 3306 is MySQL and it's not running. If it was running, it would be saying that process is listening. 3307 is MariaDB, and that one is saying that I'm listening to MariaDB on this port 3307, and this is the default local port, and this is that one is IP version 4, and this is IP version 6. So the same port is listening to that one, and then you can see listening. If I just start MySQL here, MySQL 80, I'm going to show you that that port is going to start on port 3306. So if I do a start on it, now that one is running. You can see it says running here. And then if I just go here again and check for 3306, now you see that it is, this one is running. So I'm going to just stop it again. And this is how you stop it. How easy it is, right? Now that one is stopped, and you can see it is not running. And then I could just go back to this one and just up arrow, and then see it's not running anymore. But 3307, which is MariaDB, it is running, so we're connecting to that one, and we're seeing it. And let me just stop MariaDB also, so you know that if you have to start and stop services, this is how you do it. So this running state right now, if I click on it, it says that it is running right now. And then I could just say, okay, I did it with manual, I'm going to say stop. This is going to stop the Maria database. Now it is a stop. You can see here. And then if I just go here, check for 3307, now it is not running anymore. So in order to use it, we need the database instance, which is this MariaDB, to be started. So you start it, and then there's something called connecting a string. So the connecting a string is a combination of the name of the host, the IP address or host name, which is in this case localhost, the port number 3307, and then the instance name, the database name, and then also the username and password. And that combination allows us to log into it. So if I just want to go here and say, let's start the ID SQL. So notice when I type in HE for EID, SQL comes in. And if I click on this one, it just basically gave me this very nice interface saying that you want to connect to the local host, which is the loopback interface 127.0.0.1. I say, yeah, connected to root that one. And it is connecting to root TCP/IP, which stands for Transmission Control Protocol, Internet Protocol. And on my slide, I did show you that it is connecting to root TCP/IP. And then port 3307 is the port. So I say, yeah, since I type in the password for user root, I'm going to just say open, and then it's going to connect me there. So now this interface comes in. This is the ID SQL, and it has the files and then edit, search. The menu is really nice, right? So if you're a GUI person, you can click on all these icons or go through the menu or go on the top here and then click on each of the database. And then you could do a lot with it. But then if you just also want to do command line syntax on the terminals, you have a interface here. Each one of these, once you click on, you get a session here that you can just start looking at it. Saying, for example, instead of going here and then just, let's say I go refresh here, you can see this is the list of database. If I want to see the student DB, I could double click on it and it shows up. And right here, it shows the statement, the student DB at this. So right away, if you just run this query, it will not do anything because this is what these tables are. So what you want to do is say show databases, and put a semicolon, because the next line you will just see that if I just don't put a semicolon, the next line is gonna say, oh, you have a syntax error on that. So every line is terminated by this. Now I say show databases. Now if I say use a student DB, then I could just do that one and then say, give me the student DB record here. So here, if I just do this one, notice that I run this one and then it is giving me the first line. It does not say use a student DB, because I'm just saying use DB. It is already using it, but it is silent. And he says, go ahead, do something else in order to know that you're using that one. So I say show tables. Now, if I run this one, now I'm gonna get another column here, and then that's the two tables that are there. And then if I just say describe a student, now and then describe student underscore 2. So each one of these ones you could describe them. That is just going to show you that you have these two tables. Describe a student would give you this. This is saying that this is how I define the database. A table to have a student ID, first name, last name, course being all primary key. Department name and department ID are two different keys that are defined on the department table. So here the department table, it doesn't exist on this database yet. I could create it using Python, I could create it using or I could create it using SQL IDE. And so any of these interface is okay with it. And then the student underscore 2 is a different table. So one of them, notice that this one has the student ID is defined. And then I wanted to do auto increment on this one. And this auto increment is something that you don't want to do on the primary key or ID, because when you do auto increment, this is going to have insertion and deletion and update anomaly. Auto increment should be on a value that is like, okay, customer bought 10 item of something, you just automatically increment the number. Those ones should not be matching on the student ID. I purposely created this one to show you that the records are duplicated on one versus another one. And then when you just do it on the student 2, which is the second table, you can see that it's not auto increment. And let me show you the value of them. If I just do, for example, look at the record here. And instead of doing this, I'm going to say select the store from student. And then here select a store from student underscore 2. So when you do this one, I'm just kind of like reading these two tables, right? Notice that here is the entire case for the use table. Show database is giving me this information. And then select a star from the student 1, give me this value. Notice that I inserted some record because the auto increment made the record unique for that purpose, but yet it insertion anomalies. All of these non-key dependent on other ones, and then it is allowing you to do insertion anomaly for the same record. So if I run the record 10 times, it's going to do 10 rows of that record there. Notice that these courses, pattern recognition, distributed database, even though these fields are different, but because the primary key is defined as one of the key that is auto incremented, since that auto increment changes every time, that record becomes a different number of attributes. But yet now it have insertion anomalies, update anomaly, and deletion. So if I do any record on these ones, then I could say, well, delete only record that has the student ID number 12. I could still do that one, but it had already duplicate entries for same person with same course number. I want to just say that course number is only once. So later on, when you do update, you could just normalize the table by creating, like, let's say, date timestamp, saying that is this class and the person, the student took it for fall season, semester, or spring semester, or summer, how you took it, what timestamp. That one is different than this one. Sometimes people take a class twice, and because maybe he or she takes it for 1 week and then register it, and then later on drop it. So insertion anomaly should not cause a problem for a student that this next semester come back and try to take the class again. Or if she didn't pass the class or some reason that she wants to repeat it again, or he or she, doesn't matter who the person is. So a lot of those ones, insertion anomaly, update anomaly, should not happen. And then on this one, I just created the record here. So this one, you see that all these records are having the student ID 1, and then the department, which in this case is math, is 2, and then 1 is computer science. So when I just pull this information from it, and then I could just say, well, that's great. Then go ahead and do that one. And then I'll show you how to do this one. And later on, if I just want to insert this record a second time on this one, then it's going to be a problem onto the student too. So look at the student table here. Even though this record is a little bit kind of redundant, if I just do it because the table is not normalized, this one allow it to say, okay, go ahead, run it again. It just did it. And now if I do the select statement that we were just doing it, where is the select? Right. Let me find it. Yeah, I think it is one of these ones. Yeah. So right here, notice if I run this one again, this insert is going to be updated. Instead of 18, there's going to be around 6 more, because 6 more or something. So however the number are there, that's going to be on that insert statement. So if I just run it again, notice this one is now more. So another 27 altogether. So there's more records that are duplicated. But if I just do the same thing on this one, now this one is there, and let's see if I could do insert 2. So notice this one is also doing the same record a few times, but because I have the student ID is inserted here, and then also the major name or a subject name is like computer science is 1, and then this is 2. So no matter how many times I run it, this one will just not update the table to have more entry. Notice if I run it here, it will fail, and it just says that duplication entry, Wahidullah Lutfi, pattern recognition, the key. So the first course that the chick said, it says, yeah, this entry is already in the database, pattern recognition here. So if I comment this one, is going to just complain about the second insert the statement. So insertion anomalies, you can see right here, I do that one. Now it should say complain about distributed database advanced course. So let's say we run it again here, and it says that you have an error in SQL statement. Check, okay, that one is insert into this one, host course this one, line 2. Actually, this is a syntax thing because I put a pound in front of into and rather than in front of the insert. So that was what I meant. I typed it somewhere wrong thing. So if I just try this one and then say run it now, then notice it says now distributed database. Similarly, if I just put a pound here and then just what is the course on this one? This one is also, this is distributed operating system rather than distributed database. Some of these courses I took it for my advanced, for my master degree, like the distributed database and distributed operating system, calculus and discrete math and other ones that I put here. I took it as undergraduate at the time. So some of them are graduate courses, some of them are undergraduate. But notice that if I just run this one, it's going to complain about the distributed operating system class. And you can see distributed operating system class here. So insertion anomaly is not happening on this one because we just defined a student 2 a different way to do it. And then earlier I mentioned to you how we did it, and notice here, if I just run it, the student table had duplication, that's why it's all of that. And then the student 2, it has no duplication because it is configured properly. So if I just say for each one of them, describe student 2, and then describe student, the student itself. Now I run the same statement. Let me save it. Save, and then let me, we call it something. Let's, instead of calling it query 5, because I can see there, I say student db underscore students table. So that is both of those table. I just say that's the query name. So now if I run it, notice that I have the value for it. So this is the show database. Here, this is the student ID information for the student. And then after that one is describe student is this one, which is, you can see auto increment is the problem because it is just changing. So it allows me to insert multiple duplication. For the second one, which is not auto increment on this one, and then this is the value for it, and that has duplication for the student. And then this is the table that has student ID not auto incremented. And then here's the record that is not duplicated. So that's one way you can see this one. Here, basically, you could do a lot of stuff. Like, for example, you can see here, my my demo 1 DB, my demo this one. In order for you to just do something here, let me just close one of these ones. I'm going to say student DB select and student 2 table. I could just close one of them, it doesn't matter. Or I could just write here, this one. Unfortunately, you can see after what's his name? RHEL. As soon as you just create a number of these ones open, then the next one you can either go file, load it, and then find the next one to load. And then, for example, let's say I go to say, show me the student SQL, for example. If I just do this one and then say, go ahead, open it. This one opens it, and then I could just come up, but here the tab is just gone. So I can click here and then close these ones, like here, close it, and then I could also get this icons right here. See this icon? This one allows me to just load it as empty one, similar to the other one. So if I just want to do a query here, you could do that one. It might be somewhere here like a new query tab right here. There's Control T. So I didn't have to look for this one. So in here I could say Control T, that automatically does it. So that's how easy it is. Don't look for this one if I was like, where is it? Because I opened a number of them, it was just not showing up here. But if you just close it for some reason, and then you can always click on this one, that's the next one, or you could just say File, New Query. New Query tab is going to do the same thing as shortcut is Control T. So I just learned something while I was doing this one. Let's do this. Now we go create a database. Let's say, actually we did show databases. So inside SQL, ID SQL, you could say that show me all the database instances that are there. And you can always click on these ones to look at these database instance or anything, information schema, and then MySQL. By default, you have MySQL information schema, performance schema, and then the information schema is basically your data dictionary tables here. So if I just say show tables, I could say show tables from information schema. So you could use the from statement to say, show me all the tables from there. And similarly, if you just say, show tables from MySQL, you could see MySQL tables. So a lot of the tables there, and then you could do also say, for example, function is there, and describe MySQL.function. That one is just saying that describe, go to this instance of a database and do the describe. And now it is showing you the definition of that one. And if you just say, and instead of describe, you could just say select star from MySQL function. You could say that this is what you're picking up with the data manipulation language. Since it doesn't have any data, it is not showing. Let's say from DB, is there, yeah, MySQL DB is empty. Let's see users. Users is there from, users does not have it, but maybe information schema has that one. Information underscore schema. And nobody memorized these tables inside. You just run the command and show tables, and it will show. But notice that here I just created. I just listed this one from the database schema. So now I want to just say, if I want to do a data manipulation language as well as data definition language. Data manipulation, now I'm doing a select statement, but at the same time, I could just say, create a table, student db dot, let's say users as, and then the users as, and then right here, say, select a store from users. So what am I saying here? I'm saying that create table into a database that are not connected to it, a student DB, go to the student DB and then create a user table. And then every structure, when you say that this is allowing you structured query language or a structure-based data definition and data manipulation. So here we're saying use the select statement to pull the data and all the information from this information schema users table and then create it on the student table. So now if I have the privilege to read from this table, then because I had the select statement that read the statement allowed it, that means I have access to read it. Then I also have write access to the users. So I should have this statement running successfully. And now let's see if this statement just did the work. So I'm going to say, and now describe information underscore schema dot users, and then at the same time describe student db dot users. These two tables are duplicate of each other. So if I run this to a statement, let's see what it is there. Users, student db dot users. We call it student db dot user. Okay, so it is saying that the student db dot users is not there. Let's see if it the other statement worked or not. So I'm going to say comment this line out, because this other line succeeded, right? So let's check first this line to see unknown table users. So information schema dot users. So earlier I said schema dot users, information dot users. Okay, information schema dot users. Even the first one did not succeed. So let's see if I just say users like this. Yeah. So the syntax that it cut and pasted, it made a mistake. It put this backtick on it, and it that broke it. So I'm going to just do that. So you have to be a little bit kind of like used to these tools. Sometimes they just create a problem for you, but you can figure it out what is going on. So the describe information schema dot users is this information, and then the other one is for the student db dot users is the same thing. So notice that this is all information there. So now if I just say select star from this table, because I'm not saying use, and this time I just have to say the whole thing like I did here. Select the star from student db dot users. So that will just run the same statement. Notice that here now I have the first one is having these values, which is the information schema dot users, and the second one is having these values, which is the same thing. So 6 rows here, 6 rows on the second one. So the two tables are identical to each other because you can see the structure of them. And then right here, I could also, and instead of saying this, I could also say use student db. Then after that one, if I just did this one line above this, Control X, and then just paste it here. Since on the first one, I did not say which database I want to pull the data information user, I did this one saying information. Now I say use the database as DB, then I don't need to write the database name again here. Similarly, when the select statement, because on my previous statement, I say use student DB. So now it will just do exactly the same query as we did that one. But sometimes you have to be careful when you do this kind of statement. They will work the way you want it, but then if you forgot where you were using the use statement, where you were using the information schema, the database name instance in front of the table, then you might have some kind of update when you're doing within like thousands of lines of information. So be consistent on your progress on working that you're doing here. So this is like creating tables as well as doing the definition, everything. So everything that you could do from Python, obviously you are a DBA or you're a developer, you could interact with SQL Workbench or MySQL, MariaDB, SQL ID SQL. doesn't matter what tools you use, you're doing data definition, data manipulation language, data control language inside a SQL database, relation database. So here, if I just want to say, okay, now let's say I just don't need those ones, I just say on the same line, I'm going to drop database and then my demo DB1. So this is my demo DB1. If I just run this one, notice if I run this one, it's going to drop it if I do have a access. So I wrote database this, and you don't write databases. Drop database and then the database name. Now run it. The second time you run it, it says the database already gone. So if I right click here, refresh it, now the database DB1 is gone and DB2 is there. So now if I just keep running this one, it will just say this database doesn't exist. In order to not get that error, you have to say if not exist. That is a structure that will check a logical. If this table doesn't exist, it will just give you a warning saying that the table doesn't exist. Notice this time is SQL error. If not exist, this one because the table is gone. But if I just say, go ahead, delete it. If I'm sorry, the one I meant to say if exist, drop it. You don't say if not exist. Basically, if it not exists, you create it. So, and that's what that means. You say if exists, demo one, this one now you see I'm getting a warning rather than error. Okay, so if it exists, delete it. So let's do if exists number 2. This time exists this one, it checks it, and if it is there, it drops it. Drops it meaning that number 2 now is gone. So refresh it again, and now MySQL DB2 is gone. This time I run it, I get a warning saying that warning, this database is there. So if I just say, go ahead, do number 3, and then number 3 doesn't exist here, obviously it's going to say this database as a warning does not do it. If I just don't put the word if exist, I'm going to get an error because that database doesn't exist and I didn't do a if statement checking. So in order to do it, and like this time I'm going to create that database instance. You say data definition language I showed you. You say create database if not exist. This time we say create it if it doesn't exist. So if not exist makes sense because if this one doesn't exist, create it. If it exists, don't do it. So now I created it and then I refresh it. And then MySQL DB3 is there. And then if I just say, run this one again, since it's there, it's just going to give me a warning. So that is how you create and drop databases. And then if you just say, use my demo DB3, and then you just say, okay, go ahead, use that one. And then say show tables. Show tables. Now notice that as soon as you run it, there's no table in it there. So I'm going to create a table, say create table. Let's create a table users from the other table there. So I'm gonna create table, I'm gonna call it if not exists. I'm going to call the table name as a student _2 as, and then select a star from student db dot, and then you can see here that the name of the tables are already showing what are the tables that is available for me to select. So in this statement, I say create table If it doesn't exist, then the name of the table, name it student 2 under the MySQL DB3. So this is how easy you can just create a table and run it, and now it creates it. And then when we do this one, show tables afterward, after we create it, and then run it now, show tables, show tables, right here, you see that error? If you run it again here, it says that you have a SQL injection, SQL kind of syntax error, but it is not a syntax. It's just missing a semicolon at the end of your last statement prior to show tables. So just make sure that you are terminating each of these ones with a semicolon, and you will not get an error. Now your query get a warning because of that if not exist, since that this exists there. Now, if I just say describe table, and the describe is the student underscore 2, and then here you can also comment the create statement, since I don't want to create it or even check for it. I know that it exists, and then now I just describe it, and then here's the description of it. And if I just want to say select a star from a student underscore 2, you could run the select a statement, and here's the output. And now if I just say, give me some information on this one with the matching course with discrete. So say, instead of this one, I could say where course like percentage discrete, so the discrete math I could put, or just discrete is good enough, makes it unique. And then that would be that, and then semicolon, and run it. And then now let's see what is the error. So something mismatched. I'm going to run it again, see what was the error. It says you have an error in SQL syntax, MariaDB, right syntax near the course. So let's check where I mistyped the where. So where is like that, and then where course is like that, and then that should be good. Sometimes a typo could happen when you're typing fast or mistaking something. Now you can see it is there. So if I just want to change a value of here from let's say a discrete math 1 to math, let's say change one of them from, I'm gonna just say and instead of where clause, I'm gonna say set first, set first name is equal, and instead of changing it Wahid, I'm gonna change it to Wahidullah. So let's say I want to do update my full name, and instead of short name, I say Wahidullah. And then I just say this, last name is the same. First name is longer name than short name. So I did that one, and then I could just say where first name is equal Wahid. So that would just update all my records that are with short names in there. So you're saying select this one, rather than select in this case, you're going to say update student 2, and set a name, first name to this, where first name is equal that. And now we updated it, and now student 2 is updated. Notice that if I just do this one, comment this one, and then put another select a statement here, select star from student underscore 2, and then semicolon, and then select star from my student db dot student 2. So the student DB dot is student 2 did not get modified, but the student 2 inside the demo DB3 got modified. So let's compare them. Now we have records of it, and here is the first one that has the record updated on student 2, which is this one inside the my demo DB3, and this one is the one that is not modified, so it should still have Wahid, and right there is Wahid for those two records. Okay, so insertion, update, anomalies, all of these ones, when you're making changes, you should be able to make changes on the other ones. So if I do that one with the record of, let me show you the problem with the other one. So let's go here and delete these lines. I'm gonna just start another fresh one. I'm gonna say use student DB, notice here, describe and student. This time I'm going to describe the table that has all the anomalies. Select star from student. I already showed you how we prevented it with the student 2. Now I'm going to show you the actual anomaly. So now you understand the concept, and then the way that I normalize it, I just show you the table after when we get into Python. So here, if I look at, yeah, this video is going to be long. I just I realized that I'm still on the MySQL, but I'll just jump in quick after this one to R and Python. So stay tuned with that one also. If you're just learning in Python, go to the Python portion or R portion, MySQL, SQL, ID SQL, ID SQL. So normalization, each one of them will benefit you to some level. So now notice that if I just do use a student DB and then do this one, and I run this information, notice that this is a student that has the auto increment, and the problem is this, the describing it and then record this duplicate here. So if I just want to change the discrete math, yes, I can change this one Wahid to Wahidullah, but there's inconsistency in the database because of some records that are just duplicated for no reason with just a different student ID as a result. So if I say my update statement, prior to that one, and then say, let's say update student set set first name is equal my last name, my full name, Wahidullah, and then where first name is equal Wahid. So if I just want to do that one without telling which row and which columns, then it's a problem. Because at this time, if I just do it, it's gonna update this one. But I'm going to say where the student ID is 17 or N17 or 18 or both. Let's just do a 17 only. And the student ID is equal 17. Obviously, I can use the end statement and then put student ID and 17 and the other ones, 18 and however numbers. But here I want to just do an end statement of this. Now, this one should change. The other ones is not going to change. So why is that a problem? Let's see here. That one, 17, changed right here. So this is data inconsistent change. I meant to change it for all of them, even though the database is normalized that I can just update these record there. But who is going to know all of this information, what field and what columns at what location it is different than other ones? there's a lot of inconsistency when you're looking at a table that has hundreds of thousands of rows. Even 1,000 row or 500 rows, it is really hard for the eyes to catch it, right? And then, but this number is okay even on the spreadsheet, Excel, you do it. But when you're doing data manipulation language, data control language, and your database is not normalized, then it's a problem. You're going to have a lot of data integrity issue, inconsistent records here. So that update statement did it, but then this changed to this one. Now, if I want to do it at 18, so obviously 18 will be changing, and then 17 and 18 is modified, but then notice that 17 and 18 is modified, but yet 8, 9 and other ones are inconsistent, 8, 9, and then later on 26, 27. So now if I say delete from, let's say this time I'm going to say delete from student where first name is Wahid and student ID is let's say 26. So in this case, it will delete this one, right? It will delete that one, and then look at the statement that you're doing here. 26 is gone, 27, and then 26 is gone, 25, and then 26. So now, if I do this one, but what if I just don't say the on the where clause? I mean, I just don't put a student ID. I say delete anywhere that is the name is Wahid. So 27 should be deleted, 8 and 9 should be deleted, and now the records are up to this. But watch what is going to happen after this. When I run it, now look at this one. All those records that had the username, first name Wahid is gone. Yet you have duplicate records for pattern recognition here. You also have pattern recognition here. Same thing with the other ones, pattern recognition. So if this record was inserted 10,000 times, it would have anomalies 10,000 times. And then retrieving data will be much, much slower because you have duplicate record, updated, insertion, all of that one. Please make sure your database is normalized. If you don't know how to normalize the database, consult the DBA. And then if the DBA doesn't know how to do it, so research it, do a lot of videos, a lot of books, a lot of things are written in the topic. There's a lot of expert that is going to help you. And then you are welcome to ask question. If you have any question, I will help you as well. And then being a DBA, being a sysadmin, being a software engineer for so many years on myself, I learned all of this one the hard way, and then I taught it at the school. I learned it at the school. I took a lot of distributed database courses, undergraduate, graduate for my master's degree, as well as I taught it at the university level. So I know this stuff well, and I can just help out. If I just want to design a database, obviously, I have to look at each of these normal forms in a deeper level to make sure that if I have a database that is huge, that is 10 or 20 or 100 tables or thousands of tables that are in the database, each one of them, they have different ways of you could normalize it. There should not be 1,000 tables. I just come up with that word there. It should be like 5, 10, 20, or maybe 200 maximum or 100. But all of those ones, they have to have different modules, different reasons that you're coming with that many tables. Rather than having that many tables, you want to break it into smaller databases. That way, the database are doing different purpose for different data sets. So there's a lot of concept there. You're welcome to research it. So let's go back to R language here. I'm going to just show you an R. And last videos I have discussed these other topics. I'm going to close these ones because some of them was for the previous video, or MySQL schema info. Some of them was this is all or MySQL. So last video, this one I'm going to close it. Or MariaDB. This is the one that I'm going to show you today, and other one I'm going to close so you don't get confused with that money. Now let's discuss or MySQL on database, and then con. These ones I've already showed that I'm going to close them. The one that I want to show you today is this one, MariaDB. That way I don't run the video forever. Let's get to MariaDB and then close everything else there. Okay, so as you can see here, if I just refresh this screen here, and then this one, I'm loading the library MariaDB. Or MariaDB is the module that you need to install. Last video I showed you that if you just go here under the packages and then you say click on the install, you get this interface. Whatever module that you need, like R MariaDB, if you just type in this one, you just select it, and it comes out with R Maria. The case sensitivity is important. Maria is M is uppercase, DB is uppercase, and R. So when you click on install, it will install it for you. And similarly for R MySQL, R MySQL, like last time I showed you that one. Similarly for Oracle, Oracle, like that. So each one of those instances, whether you do it for, let's say, R SQL Server, SQLite is there. So SQLite, I did also explain it last time. So whatever module that is available for it, then you could just install it that name. So for MariaDB, it is R MariaDB. You can also use the install.packages command to install it here. If it is not installed, you could say install.packages. And then here you could just put the code, say R MariaDB. So when you do this one, if you just or clicking on run here, it will install it for you. Since I have already installed it, I'm not going to install it. I'm going to just load the library. You can load the library either using the library, or you can just put pound require, require, and then the name of the library, or MariaDB. So this one, if you do that one, it will require is going to just show you that it is loaded. This one is silent. You don't see anything that is showing you as a definition. But when you do a R MariaDB, for example, if I just point to this one and I say run, notice that on this interface here, it will just say library MariaDB is loaded, right? But if I just click on the on library and then just say run this one, it's gonna just run that instance. It does not say anything. This is just showing you that line got executed. And since it was commented, this comment also shown here. Now I'm on the next line, which is connection. So I need to use a DB connect. So whenever you use MySQL or MariaDB, some of the modules are going to be available for you. So in order to know whether the functions within that module, I meant to say functions, not modules. Within a module, there's a lot of function and constants that are defined. So you could say MariaDB, and notice the 2:, which is a scope resolution. As soon as you do it, if you just tab here, then you get a list of the methods that are available. So one of them is like DB connect. This DB connect, as you can see here, it requires arguments. So the arguments here that I just did not want to just do it, I just did it without using the name, because I used library. When you load it, this library or MariaDB is there. You don't need to do the scope resolution anymore. You just use the method and then the argument to that method. And the argument to that method is right here. You can see, let me just go here. Okay, so here you can see con db connect, and then the driver name is MariaDB in this case. The host name is localhost, which is 127.0.0.1, the loopback interface. The port number I already showed you, 3307. The background process is running, and then the user is root, and the password is there, and then the instance that I'm connecting here is information schema. So it is connecting, and then I say, give me a type of it, give me a class of it, and then print out all of that one, and then do a select start from tables, which is all the tables here. If there's a tables here, which is under information schema, I'm pulling a record set, and then with the while statement here, I do a record fetch the record set, as long as that it's not record set is not completed. Not DB has completed, that one will check it. That's again a structured core language, some logical statement that you could look at the record set that you're pulling. In this case, select the start from tables. What has many records are there? Every time it lists number one of them on the record set, and then prints it out, the query string, then clear the record set and disconnect from the database. So if I just run each one of them, I could source them and run it all at once, or I could just say run it at once. Each command, as you can see, each command that is run here. So I'm on the type of the first one, the con is there. Now you say, okay, connection is established. Give me the type of it. It tells you that that's what MariaDB connection. Then it says, give me the class of it. It's gonna give you class of it. So right here, class, and then the next statement is con to actually print out the con. DB list object, all the objects of the information schema is listed here. So those are methods that are defined in the MariaDB. And then now I'm saying list the tables. Here's the tables. One of the tables is called tables itself. And then you can see here, there's a lot of them in one of the tables. Then later on, I say select the start from tables. So let's do that one. And then run it. And then now it set the record set and do a while statement. It says that as long as it's not there, fetch it. And it pulls the information. Then it is now all the information that was a list of tables. Select the start from tables. This is the record that printed out, and then at this time clear the record set and then close the record set. Okay, so this is very good. Now, if I just want to do the same thing, since I did the instead of information schema, let's do a student DB. So this is the database name. Everything else is the same, and then connection, and then select the store from tables. This one is not. We say select the store from student underscore two. That's the table that we want to pull the information there. So if I just do the same thing here, run. We keep just running the statement, and we keep getting output here, and then. There you go. The student computer science, all the information is there. And you can see, and then disconnect it and there. If I just clear this record here and then run this one, and I source it, and the whole thing runs at once. Source meaning that run this MariaDB.org with this information and pull the information, student ID, first name, last name. You can see all the records are there. And then if you want to format it nicer, you could do it with different ways of concatenation, printing, and sprintf. Yes, you can do many ways You can do it in HTML format and send it to XML format and send it to a database, send it to some file. And so there's many ways you could do that. You saw that one, right? Everything looks good. And if you just want to say, give me from the student table, this is going to give you more record, but there's a lot of duplication and redundancy. You can see that distributed operating system is a few times there. And then you can do a where clause also on the statement here. Let's say I'm going to come back here and then say where subject like percentage operating system. But operating is good enough for that one to just pull only operating system. And then now you have an error in the operating. So subject like, yeah, so when I did the subject like, I meant to say it's operating system percentage here. See that when you do percentage, that's a wildcard, but this single quote, I have to close it with single quote. So now it is pulling the information or not. Let's see, subject and where clause, unknown column subject. So I think it is called something else, not subject. Let's look at the thing. It is course and a course name. So that's what sometimes it's inconsistency with the column name, but course is good enough here. And that should pull the information, and it does. And right here is operating system distributed. So you can see how easy it is when you are just pulling the information for our language here. You can see here. So if I just change the operating system like to show calculus or database, let's see, it should pull the information for the database, and let's just run it, and it is going to give us the database here, advanced distributed database. You can see here, and if I just change that one with the, let's run it this time with not database, let's just say workhorse name like calculus. And then calculus, that's good enough. And then right there, it's going to give you this. But if you want like only calculus 101 or calculus 202 or whatever, you just look for it, and then it matches there. Since I'm getting it from a student that has more than one, I want to just get it from calculus 2, then it should just give me only 101 and 102. Notice that this one is from student 2, where course like source it, yeah. This one now clear the screen and then source this one. Notice that how nice it is. So it is 101 and then this and then that information. So it is what it is. Like if you look for just searching for discrete, and then run it. Now notice that it gives you the discrete math and elements. Obviously, you can update the records as well, rather than select a statement. So let's get started with Python here. I'm gonna minimize this one though. With Python, I wanna go to Visual Studio Code. Let's see, and to demonstrate that one, I'm going to just open up a command prompt here first. Show you, there's many ways you can get into Visual Studio Code and doing Python inside the, here and then other stuff. So let me just first show you a number of ways. Like here, if I do it from a command prompt here, I could just say cd to demo programs and then Python. So now I have a list of Python programs here. Let's look at the one that clear screen. directory star MariaDB, and then star. Show me all the Python program that I wrote for MariaDB. So there's at least 6 of them here. I will show you additional ones that are for other purpose, but let me just show you additional when I say directory /o:\d. This O means optional D, descending order. Show me the last files that I created last time. So this Maria create table 2 is one of them, and then other ones. So I have a number of MariaDB. I'm gonna just start off with the first one here. MariaDB _1. See what is that one. In order to see the content of that file, I could say more on it. And then the command line, I could do the same thing in PowerShell. I could do the same thing with Visual Studio Code. I'm going to show you what this one is. Basically, notice that on this one, on the MySQL, I did MySQL connection dash Python, right? I had to do pip install MySQL dash connector dash Python. And now I'm doing import MySQL connector that, but I commented those lines, and then for the first time, you have to do these 2 statements when you install it. But the second time, every time you use that connector, you have to import it. But in this example, I'm using only MariaDB. So I commented the first 2 lines here, and then the pip install MariaDB, I did it once. That means the MariaDB modules installed. Then you open a terminal, you just run pip install MariaDB, that module will get installed. And then whether you do it inside IDE of Visual Studio Code or Windows, whatever environment you do on that pip env stuff, you have to do that one there. So here I did import MariaDB, imported, then made the connection, and then use the connect function. Notice the other one was called DB connect. Here's MariaDB.connect. So you have to be importing the right library as well as the right methods you have to connect versus the MySQL connection, which was different. So user, and then the connecting string again is here. I'm using one time the local host loopback interface, one time the actual host name called localhost. And then the same database instance, then I get all the information that I get this. This is from the previous one. I don't need to do that one on this. So in this one, my cursor, I open a cursor. Last time I told you what a cursor is. A cursor is a buffer that you are like a file handle that you have to read and write from a file. For a database, you open a cursor, you fetch record to the cursor and like a buffer to read the record set. And then once you fetch all of the record set, manipulate it, update, insert, create all those SQL statements, you put it into the cursor execute command, and then like show database will run the execute method to run the database instance. Then you pull the record, and then for each of the record you print it out. Let's say here's the table, and then here's the select star from limit 10 city. So these ones, if the database doesn't exist, it will be a problem, right? If the database, obviously, if this one is notice that you doing a select the star from user. The other one we were doing it onto the world database. So I commented that line out, and then I did a selected statement from users and limit 5 because information schema is there. So now if I want to run this one, I could just say Python and then run it, and now the output is showing. This is the command that runs this Python script, and then this is a list of the database table, database names that is on the database, and this is the select the star from users limit 10. The first 5 records are only there, so it prints it out there. And then if I just want to open the same one in code, all you have to do is say code here. It will open Microsoft Visual Studio code, and then on Visual Studio Code, you just open that file here. And then when you run it, I already explained it at the command line. Again, MariaDB is imported. This is the connectivity to the instance. After that one, I don't need all of this one. I could comment them just to not list that printout. And these two other lines are no longer needed. I could delete it, and then these ones I could do a comment. I'm inside the VI, so I could do it fast here. And then right here, everything else is good. And now I'm going to do escape, shift, colon, WQ, save it, and then exit out. If I just run the same thing again, Python, it runs the same code. I did modify it. I just open it here. Notice my change or there. I just comment those ones and the other lines I out. And then if I run it here, I'm going to get a nice output from Python script here as well. And notice that information schema and everything. So all the records are here. Let's look at the command line again. And then notice on the command line, if I just go on the terminal here and say directory /o:\d. The next one that I just did, these ones for MariaDB, the number 2, and let's say what is number 2 that does this. So I'm going to say code MariaDB _ 2.5. I could also go under file here and then say open, and then the file name, whatever file I want to do, open it, and then I'll go to the folder and click on it. It's your choice. However you feel more comfortable, do that way. I just like this way because I could run the code, and I could also open a terminal here, run it here also. So if I just go, same thing here, say D to the C : demo Python program Python, clear screen, directory, store the file. Notice I'm on a PowerShell command line. So this PS means PowerShell. PowerShell, you can use all PowerShell commands similar to the way you do it. In addition to the fact that you can run Windows operating system, you have PowerShell more features, more ways to do it, and look at the process and store the process and manipulate it, get the service, everything. And actual program is like get dash process, for example, give me all the processes that are there. And get dash service, give me all the services that are there. So there's a lot of things to start dash calculator, start the calculator process. And then obviously I can do more manipulation, stop dash process and stop calculator and where clause and all that thing, but I'm not gonna show a PowerShell here. I'm going to just show you the Python here. All of the Python here is script is there, directory MariaDB. So like here, that's Maria _ DB2 is this a script. We could just run it here or run it from the Python. Like the one that with MariaDB1, we already did. Let's look at that one again. If we could run it from the Python inside here, you could say Python and then /, meaning from the current directory, MariaDB. So there's a physical path, relative path. The // means relative to where I am. Find that one and then run it. MariaDB _ 1.py, I think it was. Yeah. So you just run it and you just get the same output that we were doing it. So MariaDB2, if you run it, then this is the output of MariaDB2. And then you can see that it is giving information schema and then running data statement. And then if you want to do it from this one, on the terminal, clear screen, you just do the same thing and change this one to MariaDB2, and then you get the output there. You can also run it from Windows command prompt here by just saying Python in front. And if you just did not have the entry on it in front of it, and you did a command line syntax like this, Usually, if the file is associated to it, it will just run it there. Like you don't need to put Python in front of it, like I just did it, because the shebang Python executable is in the path. It finds it, so it finds that Python is executable there. So I could say send this information to a file t.text and say notepad t.text. Now I just open notepad, and then if I look for Python exec, you can see edit find. Let me just go down here so I could see the find next find, and then I'm gonna say Python. Just look for Python. You can see here the path is found. So that's Python.exec is and this path. That's why it finds Python 3.10. And if I have multiple version of it, the first one that it finds it is going to be executed on that one. And then if I just say that's great. And so how about here? If I just say Python dash version, can I get the version? Yes. Or Python itself dash v, you could get it, or just play Python itself and then you get it there. You can also import that MariaDB here, import Maria and DB underscore 2.py, I think it is. Yeah. So it just loaded and imported. When you run it, it just did it. Now, if I say dir, you can see the list of the packages that are there. One of them is that lib MariaDB. So inside that MariaDB module that I just loaded, it has information here, say Maria DB underscore 2, like that. You can see here all the information. The con is there. So if I say rather than this, to say go ahead, print MariaDB underscore to the con to see the connection, you can see it. If you want to say MariaDB.db, MariaDB, what is my cursor, or just look at the query, for example, what is in the query at the time. It says select star from users limit 5. And similarly for my cursor, see what is my cursor pointing to? My cursor, and that's the function that my cursor dot connect dot cursor, actually. That's the one. And then let's see, the DB is the sys DB. At the time we were connecting on the sys DB, and then there's a lot of stuff here. MariaDB. And then that's the path to initialization and net.py and that package for constructor. So we will not get into deeper level here onto this, because I'm already showing you from Visual Studio Code and other ones. So I close that one, and this is another way to open it. And then I told you that you can open the same files in other ways. You can also go under File here and say open file, and then since I'm on the programs Python, you could just look for MariaDB, and just by searching here Maria, and then all the MariaDB are showing up here. So let's say, for example, MariaDB 1 is already shown, 2 is already shown. MariaDB create table. I want to just jump in one go through all of that one. Student DB, create student DB. Obviously, I want to just show you, maybe student DB is the one that I want to show you the next, and then, yeah. So student DB here, notice on this one, when I did the student DB, I created a number of tables. Here, one of the tables was student DB. Create a database if not exist. This is when you create the database using this. Since I already ran the database previously using this method, the database student DB got created. And then say show database, it's gonna do this one. If not exists, then this is still going to work because this database exists. So then show database is gonna show the database and then run it. List of the database before and after. So before we do it, it's already has the list. And if not exist, this one line 1, invalid syntax. Let's see, if not exist, query database if not exist, student 1. Since it exists, actually student DB, it is not going to do that one because it's a warning. Remember, the warning comes in because it says if not exist. So I'm going to comment this line out, and then this execute command is not going to do it, but I want to do this one, show databases, and then list database, and then print it out. So this one will save it. Let's see if we make a change here. And now we look at the output, it looks good. So it just, because the database already existed, we just didn't want to check there that warning that was coming here, that warning through an error saying that the SQL exception on this line. But since the database is there, we know it is there. We just want to list them, and then here's the number of the records that are in there. So this is one of them, and let's check out another one. I'm going to show you two other ones. Let me just say on the command line, I go back here. Okay. So right here, I want to show you clear screen directory store.sql and .py. And then we want to just say student. Clear screen directory store. Sometimes I type in clear like this. That means it should be on Unix as well as PowerShell. If I go to PowerShell, and then say directory here, and then I do a clear, it works. I do a clear, it works. Clear dash host, it works. All of that one is the same thing. Control L, it works. Like this one, Control L, it does. Directory, clear and dash host, it works. And then directory clear, it works. Directory clear screen, all of those one. But if you're out of PowerShell here, the only one that works is CLS, clear screen. If you want just type in clear, it's not going to work because that's not the PowerShell command. It's not you're on a Windows operating system. You can see version here and CMD. I'm on the Windows operating system, not PowerShell. And that's why the C terminal is there. Okay, so at this time, let me just do a clear screen, and I do a directory store.py, and then I say find /I, and then search for a string of student. So this one, it says list all the files that has the extension .py, then search for this string and that has the name. Easy way to do is to say directory store student store. That will just automatically give you the same output, or store.py, and that will also give you the same thing. So there's many ways to look at one. So in this one, I'm going to show you this MariaDB create student table. Let's do that one. Say code, and then I'm gonna put this one as argument, and then open it. Here, this one is creating. So here I just put like a template. Whatever database, I just do it on MariaDB or something. I just write the definition and then some kind of who wrote it and why I wrote it and what is it available, where is it available, all of that. Import MariaDB and then connecting to the database schema, opening a cursor, show the databases, and then list of the database before, and database name is DB, show database this, and then fetch the record, and then pull the record here. So if I just run it, and then it just gives me the information, no matter how many times I run it, all it is just from the database, it shows all the tables that are there. Another file that I want to show you here, I'm going to say screen find slash, you can say find string slash I, and then search for the statement that has create table, and then store the file. So, and there's a number of them: update customers, update this, select customers, MySQL DB, MariaDB, create table 2. So this is the one that I want to show you here. MariaDB create underscore table 2. Let me just show you that one. I'm going to say code MariaDB underscore create a table, create this one. So I'm going to open this one as student 2, the one that I created afterward, because the first one had a problem with database being having incremental, right? So then this time I created, let me show you the incremental first, that way you know that the word increment, I'm going to say create table increment. So that is plot sign cosine MariaDB underscore table. This is the one that I want to show you. Okay, so I'm going to say code this. So the first time I wrote it, remember that insertion anomaly, I created the table department to do the department, and then also the student. The student noticed that when I did a student ID, in order for me to show you the anomaly insertion problem, I created as a student ID int auto increment. And I say don't do auto increment on the primary key stuff, because there will always be a new unique number, and then that way you have multiple attributes that are going to be having duplicate records, and that is going to be anomaly issue with insertion, update, and deletion. So in order to avoid that one, I created this other table, and this other table, let me just, this other table was on one of these ones that had table 2 right here, this one. And notice that here, when I created the student ID, I just said int, but then I just added a primary key as student ID, first name, last name, course. And that's why when you have the select statement here on the one that it is not having duplicate, let me just go under student 2, and then pull the student 2 record here. And then you can see for student 2, when you run it, the student 2 is having all the anomalies gone. So for each one of them, like math major is number 2, department and computer science major 1, and all of those ones are user ID is 1. So there's no 2 entry for one user ID, and then every one of them is unique as a record. In the insertion that we tried it here, and no matter how many times you insert it, it will always complain. So like, for example, if I just comment this line now, the next time I just try it, it's gonna go on this object-oriented course. So if now it says object-oriented programming is not allowed because of this there. So if I don't comment it, each one of these lines will complain about all of them. The first row that matches a duplication, it will not allow it. So I'm going to say file save, so I could go back to my original one, file save, yeah, and this save. Now you run it and just says pattern recognition, the first one that I showed you earlier. So that is not allowing duplication. And with the select the statement, obviously, for the other one, select the statement, insert the statement is going to allow you duplicate entries because it had student ID incrementing every time. So that is why I did that one. And now, since this one, student two, we don't have a table called department. I'm going to just run this code here on the department, and notice that here I commented out this line in order to just not run it, but now I'm going to run that line, and these other statement that I'm doing here are all okay to do this one. Show a student database, show table from student DB. Okay, so this time I'm going to run this query here. It says create table if not exist, department ID, int auto increment primary key, and department name var character 20. I could do the department ID something else, or whatever you want to do. It's up to you. So now I declared this one. I'm going to just look at that record, and then we could insert some record in the database once we do it. But before I do this one now, let me show you here. And the query that we just opened here, say new query. So right here I say use student DB, and then say show tables. So this one is telling me that I have only student and student two and users. I want to just drop table users. I don't need that one because that was just a demo that I wanted to show you how you can use the select and create table combination, statement combination to create the table. So here I do show tables, so that table users is gone, but this one is having anomalies and this one doesn't. So if I say select star from student underscore two, and then also select star from student, and then notice that the student has anomaly and the other one doesn't. So as I showed you earlier, but like I mentioned earlier, student, let's see what is the error. Show tables, drop table. Okay, drop table if not exist, right? If not exist, if exist. This one will give you a warning now. If you don't check for it, it's going to not go to the next statement. But now it gives you a warning because it does not exist, which is okay. Or we could comment it out saying, even don't do that one, don't even give me a warning. So now it runs that. This one, show table, select star from student. Now you can see a student is having duplicate records, but the student two doesn't have it. The student two only has those number of records, and then there's no duplicate. For the same course, it's not written twice. You can see here, there's a number of them are primary key, but the course names are different. Distributed operating system versus distributed database and so on. How do you look at the tables? So look at this one. When we did the show databases, show tables, we see only this. But now let's create through Python, and right here we run this statement. So I'm going to do a save WQ, and then just run it here. Now I run it, and then error out, see what's the error. Rows, okay. This is the cursor does not have a record set. That's fine, because when you're doing a query, and if you're just uh, doing a query without listing of the cursor, like a selected statement that I printed out here, somehow on the primary key of the first one, I did this one. And then right here, I printed out, which is showing the table got created. Let me just check on this one time. So the way you check your code to make sure that there's not something left over from last code that I've added. So I go here, I make a connection. That's the show database. So show database, I don't need to do the show database. Here, I'm going to do, actually here listed, which is that one is fine. Query is there, my cursor record set is that is there, so it prints it out. And then here, this one is commented, and close comment here, these are comment. Query show tables from student DB, and then show table from student DB, my execute. So this one, actually, I don't need to run it anymore, because the other one is going to just do what I want to do, which is create a table. Let's see, query this one, and then this one, fetch all, no record set, and there. See how easy it is to modify it, but get still an output that is not working, line 34. So let's look at line 34. Line 34 is record my, okay. So we don't need to do a fetch here, because we're just saying go ahead, create that table if not exist. And since that table actually is already done, this record set the second time it comes in, because of that warning, if not exist, it's going to just be a problem. So the only way you could do is that go back to here and say, show me the tables. And now you see that department is there. If I drop the department, then I run it, I will not get the error the first time. So let's do this one. Say, and drop table department. So let's say we do that in this one, just to drop it, and then here the show tables we do afterward. Control X, and now we should not have that department there. So right here you can see it is there, and the drop table if exists. Again, this if exists is just logical. If it doesn't exist, it still give you a warning. So you get a warning like this, that's there. So since it doesn't exist, these are the two table or showing, and here is the list of the tables on the student and another one. So if I run my Python program now and say, go ahead and run the same Python script again, and then this time it's gonna just does the work, and then say record set is empty, but by this time it already created a database. And so now I don't want to drop it this time. I want to say show tables. So comment this line out, and then this time I'm going to say run this, and notice that the department is there. So since the department is there, say describe department, and then we can see that the department is description is right here. So auto increment, department ID, and then department name, and all of that information is accurate. So if I just want to insert some record here, let's say insert into department, and department, I could say the keys here is department, depart underscore ID, comma, depart underscore name, and then I'm going to say values, and then I say department ID, I'm going to say 1, and then a value, I'm going to say computer science. And then that would be inserting that. And then the next one, I'm going to say insert, let's say the second time, I'm going to insert number 2. And then I'm going to insert math here. Okay, so since this one is a primary key, the ID gets incremented. If I just insert the same record second time or third time, it might allow it if it has insertion anomalies. And you can check it only by inserting record to make sure that it is there. So now if I say, after that one, I say select store from department. And notice I have to put semicolon at the end of each one of these. A statement, now I run it. And then this record that is there is added because of computer science and that. If I run the same again, and if I see a number 3 and 4 is added, and CSC is duplicated, then it's a problem. And then on that one, I could correct it. See that one says duplicate key is not allowed. So that is good thing, because right there, it prevent me from adding it. So if I just say, okay, go ahead, since this one is not allowed, is this one going to be allowed? Math is gonna say math is not allowed either. So it's gonna say complain about math duplicate entry key is number 2, which is that, which is good. So and instead of commenting them, let's say I'm gonna change this one to 3, and then I'm gonna say electrical engineering, and then 4, I'm gonna just say mechanical engineering. And then let's add a fifth one by just adding this line here, Control C. I'm going to say the fifth one, I'm gonna say art. You can add biology, physics, whatever you want to just do it, that's okay. You can add it. I'm just showing you this insert the statement will succeed because those are new IDs with different names, so those ones will insert. Now, if I go here on the select the statement, here from this department, you can see those are recorded added. So it doesn't matter how many records I add, it will allow it. So now I go the same thing here, say change this one to physics, and then this one is number 6, let's say. And then at this time, if I run it, the first one, number 3 is going to be saying it's not allowed, because we have the constraint here. Duplicate key is not allowed. That's when you know that your database is normalized. So if I just comment this one and this one and art commented, but only allow physics, now I should have an entry to physics, and that worked, and then right here is physics is there. Okay. So this is how you could normalize a database to have not duplicate entry by breaking down into smaller fields that the primary key, every table has a primary key, and then the rows or attributes, rows, order of rows that cannot predict, cannot dictate the order, and then also group names cannot be duplicated, and then the fields or each an attribute has to depend on the primary key and so on. There's a lot of each one of those normal forms we discussed. I'm not going to review it again because it is already 12:37. I need to sleep as well. Okay, take care. God bless you all. I hope you enjoyed it, and if you haven't subscribed to our channel, please make sure you subscribe. And the two channels that I have is MyWebUniversity. MyWebUniversity channel at YouTube, which is this one, and then I have a lot of videos, and then some of them are very popular, some of them are going to be popular. But the more you share with your friends, the more they appreciate you, the more you can just learn and enjoy your life. God bless you. And then you could do the same thing in Farsi version. And also I'm going to my website, which is the entire book online here, practically. Take care. Bye-bye.